Good day everybody. Today we're going to have a basic look at the layout of the Arduino UNO board. We're also going to install the IDE Arduino software onto our PC, connect the board to the PC and write a short little program and upload it to the board to ensure that our computer is correctly communicating with our Arduino UNO board and the board itself is functioning the way it should. Before we go any further, what I'd like to do just to motivate you guys, if you are new to Arduino, let me run through or just show you a couple of examples of projects that have been done with this Arduino UNO board. So if you would like to learn how to build projects like these, please do subscribe to the channel. Let's learn, let's build, and let's grow together. Do you have any experience at all working with electronics, or are you totally new to electronics? Please do let me know in the comments below. I'd love to hear from you guys. Okay, so the Arduino UNO R3 PC board, that's the current version of the board that's circulating at the moment, and that's the one we're going to take a basic look at. So firstly, we're going to look at the USB connector. This is where you're going to have a USB cable running from your PC to your Arduino board. This cable is going to serve two purposes for the most part. Number one, it's going to allow us to communicate with the board from our PC, upload programs that we've written to the Arduino board from our PC, and it also provides the board power. Then we have the power connector. Now the nice thing about this is you don't want to have this Arduino board plugged into your PC all the time to allow your project to function. So once you have finished coding and uploading the program to the board, you can simply either plug in an AC to DC adapter, or you can use a battery. We then have the reset button on the board. All this button does basically is power cycle the board. So what will happen when you press this, the board will just restart running the program from the top again. Then we have a power LED that's built onto the board itself. So you'll notice when you do plug your USB cable in, or you do plug an independent power source in, that LED will light up to indicate to you that the board itself has power. Then we have digital pins numbered 0 to 13. Now these digital pins can be configured as inputs and outputs, and we will be using these digital inputs and outputs in most of the projects that we're going to be doing. If we take a really close look, you'll see another LED etched onto the PC board. This LED is actually connected to pin 13. The nice thing about this is it allows us to write a little program using pin 13 and be able to turn the LED on, off, make it flash without having to actually add an additional LED and create a circuit. We'll actually be using this later on in this video just so I can show you how to write a short program, and we will confirm that our board is functioning correctly. Then if you look at pins 0 and 1, these are RX and TX pins. This basically allows you to send and receive signals. We'll get into a lot more detail with regards to these in later videos. But the nice thing about these two pins is that there's also two LEDs on the motherboard. You'll see marked TX and RX. So what will happen is when data is being sent and received on those two pins, those LEDs will flicker. So if you're doing a project and it's not working the way you'd like it to, these LEDs can be quite key in troubleshooting or showing you whether or not data is actually coming in or going out of those pins. Then on the other side of the board, you'll see pins A0 to A5, 6 analog pins. Now the nice thing about these analog pins is they give you access to an analog to digital signal converter. Because obviously the microprocessor will process everything in a digital way, but this does allow us to connect to and communicate with analog sensors and devices. These pins can also be reconfigured and used as digital inputs and or outputs. Then next to the analog pins, you'll see we have some voltage pins. We have a 3.3 volt and a 5 volt pin there. And as long as you have your USB cable connected or independent power source of 5 volts or more, you will have access to the 3.3 and 5 volts there. So basically, if you take a multimeter and measure from ground to this 3.3 pin, you'll actually see you are getting 3.3 volts out of there, and the same applies to the 5 volt pin. So that's a quick basic look at the Arduino board. There are quite a couple more components on the board, but I think in the best interest of keeping it simple, let's not go into too many unnecessary things. As and when we need to learn about new components on the board, we will do that. And then also just to note, this big black chip in the middle, that is the microprocessor itself. That is the heart of the board, and that's what does all the computing and processing of the program. All right, guys, so to get started, we need to go to this URL. I have included it in the description below for you guys, so that we can download the Arduino IDE software. So if you follow the URL that I've given you, you will land on this web page. Now, you will see that you can code online, but what I would recommend is download and install the software on your machine. So let's do that now. So the version doesn't really matter. You just want to download and install the most recent version. So if you look at the column on the left, you do get installers for Linux, Mac OS, as well as Windows. So you want to click on the Windows installer. It will then download, and I'll take you through the installation once your download is complete. All right, once your download has completed, you can click on the file, the setup will start running, and you will get to a window that looks something like this: Arduino Setup License Agreement. You can click on I agree. You can leave all the options selected that are selected. We'll just run through a default install. Okay, the installation is now complete. You will see a shortcut on your desktop that says Arduino. Let's go ahead and open that. First and foremost, what we want to do is make sure that we can successfully connect our board to our computer. Okay, so we're going to connect our USB cable to our Arduino board and plug it in there. Once it's plugged in, you'll notice that there are some LEDs on the board that light up, which indicates to you that the board has power and is successfully connected to the computer. Now back to the computer screen. Okay, so now that our board is plugged in, a quick and easy way to check that the computer and board are able to communicate with each other is this. If we click on the Tools tab at the top, and we go down to the board option. Here already you can see it has the Arduino UNO selected. This tells me that there is definitely communication because I did not specify at any stage which type of board I was connecting to the computer. So I'm quite happy that the board is able to communicate with the computer. Next, a brief look at the programming and the coding. So you'll see at the top here you have void setup, and then you have void loop. From a structure point of view, what we're going to put in at the top here is any configurations that we would like on the board. If we want to use specific pins, would we like them to be input and output? Do we want to declare any variables? And that type of thing. First and foremost, we've decided that we're going to use pin number 13, and we want it to be an output pin because we want to push voltage to the pin so that the LED comes on. So what we're going to do here is select pin mode, open brackets, and then we need to specify two things here. Which pin? So first of all, we're going to say number 13, comma, and then what would we like it to be, an input or an output pin? We want it to be an output pin. Now, a couple of important things I want to touch on quickly with regards to syntax. First of all, when specifying commands, instead of separating words with spaces, we use an uppercase letter at the beginning of each and every word, starting from the second word onwards. So pin mode, you'll notice the text is in black, which means that the software has not recognized it as a command. If I now change this M to an uppercase, you'll see immediately the command changes color, which gives me an indication that it's correct and the software is happy with that. The next thing to look at when specifying if we want it to be an input or an output pin, we need to use uppercase here. Again, you'll see the color of the command changes, which shows me that it's correct. And then something else important that you want to remember when specifying commands, we need to always end a command with a semicolon. So almost 99% of the time, you'll have a semicolon at the end of each command. Okay, so I'm happy that we've now, from a configuration perspective, declared everything we need to. We're going to be using pin 13 and we want it to be an output pin. Then we move on to the loop section, which is what's going to repeatedly run as long as the board itself has power. What do we want the board to do? We want the board to give power to the LED. So what we do is we're going to say digital write. Remembering the uppercase letter, you'll see the color does change. Open brackets, again, we need to specify two things. Which pin do we want to output to? It's number 13, comma. And what do we want to do? Now, when using a digital pin, we can either output a high, which would mean send 5 volts, it would be on, and to do that we use the word high. And if we wanted to turn something off, you would use the word low, and in that case it would send 0 volts. Close brackets, and like I said earlier, semicolon. That's it. So we now finished putting our coding in. Now, a quick way to check that your syntax is correct and understood by the computer is you can use this first button here, which is verify or compile. So once we click on that, the software will compile, it'll run through and make sure it understands the code and it doesn't detect any errors with the code. There we go, done compiling, no errors. That's beautiful. At this point, we can upload this to the Arduino board. Busy uploading, done uploading. So this code or program that we've written now sits on the Arduino board. Let's have a look at what the results look like. If we take a look at our board now, the LED right next to pin 13, which is part of the pin 13 circuit, is on. So that's what our program is currently doing. Let's say, for example, now we would like to make that LED flash. Let's have a look at that. Okay, so we've written this code. Remember that this gets looped the whole time. So if we want it to flash, we should then put a command here that will say digital write pin 13 low. That will then turn it off. We can again compile, make sure that it does successfully compile. Done compiling, that's great. And again, we can upload it to the board. Well, all that I can notice is that the LED is still on, but it is somewhat dimmer. What could be wrong here? Okay, let me point out something quite important to you guys. A computer processes things relatively quickly. So when I applied this second command of turn the LED off, what I noticed was the LED got dimmer, but that's because this loop is running so fast that it's turning on off, on off, on off, on off, on off, that we're not really able to see the LED blinking nicely. So what we are able to do is run this command, switch it on. We can then tell the program to wait for a specific amount of time and then turn it off, and then again wait for a specified number of seconds, and then turn it back on. So the command that we're going to use there is delay, and this always works in milliseconds. So we can say 1000, which will be 1000 milliseconds, which is a second, and then we turn it off, and then we want to delay again for another 1000 milliseconds and turn it back on. So what's going to happen now is it's going to turn it on, wait for a second, turn it off, wait for a second, turn it on, wait for a second, and loop like that. Okay, let's compile the sketch to make sure it's happy with our syntax. We haven't left anything out. It is done. And again, we'll upload to the board. Let's have a look now what it looks like. Look at that. Absolutely beautiful. On 1 second, off 1 second, on 1 second, off 1 second. Okay, so you guys have just successfully written your first piece of code, uploaded it to the board, made sure that your board is communicating with your PC, made sure your code is performing the way you wanted it to. This has been a great exercise. If you guys enjoyed this content, please do subscribe to the channel. There's going to be more coming, and there's some really exciting projects that we can climb into. But what I want to do is take it one step at a time. So as we're moving to more and more exciting projects, we're learning all the bits and pieces of technology along the way, understanding the components, how they work, why they work, and build onto our coding knowledge bit by bit. The coding can be quite intimidating, but I hope the way that I've explained it today was useful and understandable, and we'll just keep building on this knowledge. So, guys, until the next time, keep it real.